Yeah. Is it what? I don't think so. You're pretty close though. You're very close. For some reason, Jacob, I couldn't see you over there. Make you absent. I don't know. You're like really low. So let me fix that, okay? I see you now, and then I'm up. Okay. So I want to remind you of a rule that we talked about with square roots, but you may not remember, and that has to do with denominators. No, the calculator will do it, but if you fully rely on the calculator to get through this section, you'll find yourself one day in math class feeling like, I don't know any of these properties, I'm confused and lost. Okay? And that's because you relied too heavily on your calculator when we reviewed the properties. So sometimes, well, it catches up, but it doesn't catch up for maybe like a year or so. And you're like, man, why do other people know this and I don't know it? And then you think back in time, you're like, well, I did cheat on an entire chapter last year. And then maybe that's why you don't get it as well. Anyway, that's not always the case. But also, why are the words confusing? We need to talk about vocabulary. This says the denominator must be rational. What that means is that in another more straightforward way, there shouldn't be radicals in denominators. Okay, so I think it would be a lot more straightforward if it said simplify, period, rationalize the denominator, or clear the radical from the denominator, but they don't tell you any of that. You have to kind of memorize rules as you're learning it. You also have to accept these new goals in your life. Your goal here would be to have the cube root of 5 to the third. That's a useful moment because, Kenny, why is this the goal? What's useful about this? How does this simplify? Just right here. Yeah, the index and the exponent cancel, and this would leave a regular 5 down here. So instead of 5 to the first, I really want this. I really want 5 to the third. And you have to kind of think creatively to create that. Well, I know when I am working with fractions, as long as I multiply the top and bottom by the same thing, I'm following the rules of fractions. So I'm going to go ahead and multiply in. I need 2 more, so I'm going to multiply in 5 squared. Is that color dark enough? It's really not, is it? I'm going to multiply in the cube root of 5 squared. I have to do it to the top as well to keep things equivalent. I've run out of room, so I'm going to come over here to the whiteboard. So this is now 1 times the cube root of 5 squared in the numerator, and the cube root of 5 to the first times the cube root of 5 squared in the denominator. So that's the cube root of 5 squared over the cube root of 5 to the third. Uh-oh. That's a 52. And then here's where the canceling comes into play. So this is the cube root of 5 squared over 5. Yeah, this is considered more simple than how it started. And the reason for that is I know, but think about this. We can divide something into 5 equal parts, okay? And 1/5 of something is 20% of it. So I could multiply the top by 20% and know what I have, okay? Because this denominator is a 5. 1/5. The denominator we started with is irrational. This is a decimal that goes on forever without repeat or pattern. This is like pi. We don't want to divide by something irrational. We can't visualize it. We don't understand the equal parts. So we rewrite it in such a way that we can then look at, oh, okay, 5 equal parts. So it's just about the denominator being a little more simple. The whole thing might look more complicated, but we consider that one more simple because the denominator is a regular number. I was talking about that when you were talking to Leon. Yeah, you were. Yeah, you were. Because of the goal. The goal was to have 3 of them, and we only had 1. So I think creatively about how many more do I need? This time I just needed 2 more. Had it been 2, then I would have just multiplied 1 in, because I know the goal. Good. Who else wants to ask a question about this? Okay. Let's look at yesterday's assignment. You can ask some questions. You should be able to review it. I had a talk with 3rd period about how much they were using their calculator on this. How'd we do 4th period? Wow. Actually, you're pretty much even with 6, so that's not bad. That's the number of submissions, not how many are right or wrong, but it's an indicator of participation. I think 5th period has more time than any other class, and that's why they always have the most. 1st period, they already got to ask me questions they probably submitted this morning. Oh, that's 3rd period. Anyway, this is going to go up a little bit in just a minute. I'm sure you guys are going to submit late. I don't really know what to do about that. I just want you to learn it. So hopefully you wrote some steps down on paper and you know which ones that you're confused about, and you can ask right now. Does anybody want to ask a question about yesterday's assignment? Any one of them you couldn't get right and you don't know why? I think we did get a lot done in class yesterday, but no. Did anybody totally use a calculator on these and wants to see how to work one out without the calculator doing it for you? What are you looking at, Leo? What are you doing? Oh yeah, that's the really hard one. I did that at the end of class yesterday. You know what makes that one so difficult is it's a cube root and a 6th root. But I did it at the end of class yesterday. Yeah, I'm not going to do it again. Does anybody have a question about any of these I did not do? Jackson? Did you get them all right? Yeah? Let's do 14. Yeah, everyone just guessed and they want to move on, but understanding it's the goal. So all of these have the same exponent. In that situation, you can put the exponent outside of parentheses. Because they all have the same one. So I'm going to rewrite this as just 2 times 16 over 4 and the power of 2/3 is outside. So now I know 2 times 16 is 32. So that's 32 over 4 raised to the 2/3. 32 divided by 4 is 8. So I would think most of you guys got this far, and then you really aren't sure how this relates to the multiple choice. This is a base 8, and those are base 2 and 4. One skill that you just acquired that I want to encourage you to try is rewriting in rational exponent form. I mean, radical form. You bring your 3 down and around, and it becomes the cube root of 8 squared. Do you all know the cube root of 8? What is it? 2. So this is 2 squared, which is 4. So I used the properties. I went through it step by step. And this is helping me learn properties of exponents. It's helping me recognize roots a lot more than just putting it in the calculator. So the goal isn't just to get the right answer. The goal is to practice and use the properties. Joe? Let's do 13 next. See what we can practice there. Several right ways to go about this. I'm going to go ahead and add exponents because I see the same base. If you did this on paper, I'm curious to know how many people actually wrote 9 down. Because I'll see on a test question, a lot of students will make this 9. We'll add the exponents, but they will still write 9 down. But this is not 3 times 3. This is not a 3 at all. A 3 with this exponent is some sort of decimal. So this is a decimal times a decimal. There's no 9 here. So I'm going to do big base 3, negative 2/3 plus 1/3. And I can do that because it's the same base. So negative 2 plus 1 is negative 1. And I'm still keeping that exponent of negative 1 out there. Then we have a power to a power. We multiply power, so that's negative 1/3 times negative 1, which is where 3 to the 1/3 comes from. Good one. Should we do one more? Let's do 16. Oh yeah, there's a typo here in this program. This large should not be here. You want to do it the more advanced way? So yesterday I would have just multiplied 5 times 125. But you know that 125 is 5 to the 3rd, right? So when I multiply this, it would be 1 big 4th root, 5 to the 1st times 5 to the 3rd, which is 1 big 4th root, 5 to the 4th, because you add exponents. Cancel the index and the power, and there's your answer. That's the more advanced way to do it. Particularly today, you want to start seeing all of these numbers and rewriting them as a lower number and a power if you can. So if you know that can be a smaller number with an exponent, that's the right route to take right away. Any more we should do? Let's do 17. I don't recognize 486 as being a power of anything. But what I do see is that it's even, and I know even numbers divide by 2. So I know if I make this into one big radical, I can go ahead and do that division and have a smaller number to work with. So that's the fifth root of 243. I recognize 243, but you may not. So go ahead and write this list down if you don't recognize these numbers. We're getting into some higher numbers that we haven't seen as often. 243 is 3 to the 5th power. I could require you to make flashcards and then give you like a no calculator test on all these, or I could just tell you to remember it and let you decide the best way to remember that. So the 5th root of 243 is 3. Any more we should do? Okay. I will put this up. I want you guys to go to page 429 and read the conditions for radicals, the rules, and look at the examples, and I will make today's assignment available to you. All right, we have some conditions here. These are things that mathematicians use as they're working through formulas and proofs. Say a radical with index n is in simplest form when there are no perfect nth power factors. The radicand is the number underneath the radical bar. The radicand has no fractions inside it, meaning the number under the radical bar is not a fraction. And the radicals do not appear in the denominator. The denominator is a rational number. To meet the last two conditions, rationalize the denominator by multiplying the expression by an appropriate form of 1, which means the same thing on the top and bottom. That eliminates the radical from the denominator. So I wanted to catch your attention on this right away. So we already did it in Bellwert. Rationalize the denominator and made a real number denominator. So when you're ready, open up today's assignment and I'll work through. Let's say we go, I'll work through 7 or 8 of these with you. And then you guys can try some on your own. Yeah, this is book pages 433. It's 20, so it starts as 20 through 42 even. And then it's 19 through 41 odd. So it starts with the evens and then it ends with the odds. I see that. It's always an exciting day. Well, his pen exploded. His pen exploded. That's exciting. Why is this day exciting for you? It's Friday? Oh, you're pumped. You are really excited. You guys, did it show up yet for you? Oh, yeah, right here. Yes, you may. Yes, you may. All right, let's look at the 4th root of 288. Did I say 4 or 5? Okay, well, I have my list of numbers to the 5th power here. 288 is not in it. 243 is, and so is 32, and so is 1. So if I have to simplify this, I'm wondering, does 288 divide by 32? Anybody? Ooh, it does. Somebody picked up a calculator and tried it. 288 divided by 32 is 9. And I picked 32 because I'm looking at numbers to the 5th power. Two times 2 times 2 times 2 times 2. Okay, that's cool. All All right, so now I can separate this. This is the fifth root of 32 times the fifth root of 9. And the fifth root of 32 is 2. So this is 2 times the fifth root of 9. Try to type it. I don't think you should type the dot. But when you click in this box, the keyboard will pop up. If it's the basic keyboard, you won't see the right radical. It has to be you have to toggle to the more advanced keyboard, but I believe the program takes you straight there. So everybody see if you can at least type in the answer correctly and get it right. Then we'll go to number 2. For some reason, I only got to like number 5 last class, but we're doing better. We're doing better now. Wait till he gets back from washing his hands and then you can go. So you're writing this on paper so you can refer back to it. All right, if this were yesterday's assignment, we would turn this into one big fraction and reduce 4 over 27. But do 4 and 27 reduce in any way? They don't have any common factors. But they are really special numbers. They can both be rewritten as a base and a power. I'm not concerned with the top. I'm only concerned with this bottom. It says write it in simplest form. Simplest form means the bottom should be a rational regular number, not a radical. Yes, so 27, you should recognize that you can write it as 3 to the third. So you're thinking to yourself, can I write this as a smaller number with an exponent? It was a pretty nice pen. All right, so you probably didn't know that this would ever be a goal of yours, but here it is. We're setting goals here. Goals for numbers. When I look at this denominator, my goal would be the 4th root of 3 to the 4th. So this is a new goal for you to set as far as all the times you're working with numbers is for an index and an exponent to match. The reason that's our goal is because the exponent and the index are inverse and they would clear to be a regular 3. So we have to think creatively, how do we go from this to our goal? We need to multiply 1 more in to total 4. So fractions are great because you can change them any way you want. As long as you do the change to both the top and the bottom, you're following the rules. So I'll also have to do the 4th root of 3 to the 1st to the top. So this will be, the numerator is 4 times 3 to the 1st, and down below would be 3 to the 3rd times 3 to the 1st. And I've run out of room again. Hope you're writing it down so that you have some chance of recalling this anytime. I recall. So this would be the 4th root of 12. And this would be the 4th root of 3 to the 4th, which was our goal. Mission accomplished. I'm going to go ahead and and make that a regular 3, and then I'm done.
What if the top would be 12?
I can see. That's actually considered the most simple form.
If you multiply 4 times, wait, doesn't every number have like a invisible one?
Mm-hmm.
So why wouldn't it be 12?
It's only when you multiply the same base that you add exponents. So 4 and 3 are not the same. You would not add their exponents. Well, you're still kind of confused about when to stop. You know, like, is there something more I can do, right? Two to the fourth is 16, so this 12 is less than 16. So and we got a regular 3, and we can't divide them because one's inside and one's outside. Let's move on. Any questions? Are we ready to move on? Okay, good. All right, 7 and 4 do not reduce, so I'm going to separate the fraction. So this is the cube root of 7 over the cube root of 4. And if possible, I'm going to make any large numbers smaller by writing them as a base and an exponent. Four is the same as 2 squared. So you're really acquiring a lot of new skills with numbers here. One of the main ones is seeing large numbers as a smaller number and exponent and rewriting that. You're practicing it. We're not showing it to you and saying, now you know this. That's not what's happening. I'm not saying you know this now. I'm saying you have to practice rewriting these numbers, and eventually you'll start to see these numbers this way. Okay, now I've rewritten this as much as I can. Now I'm going to consider my goal of getting this to be a rational number. It's a cube root, so my goal is to create a cube root of 2 to the 3rd. Do you guys think I should move your seat? Like, I don't know if I'm doing my whole job right now by not redirecting you. Like, I don't think you're doing any of these right now. And are you distracting them? Are you doing them? Okay. Are you on 3? Okay. All right. You got it. So it's only one person over here? Well, that's not so bad. And Rowan learns really quickly. So you could probably just lock in for one of them and get there. Get the idea? Rowan, what do I need to multiply to this one? I'm right here. I need this to look like this. Mm-hmm. So that's called a cube root? Good. So do you feel like you already know it? And that's why you're not practicing? You do need to practice it a little bit to show full comprehension. You know? Like, just because you see it and get it doesn't mean you can do it on your own just yet. So the top is now the cube root of 7 times 2 to the 1st. The bottom is the cube root of 2 squared times 2 to the 1st. That's the cube root of 14. And that's the cube root of 2 to the 3rd. So that's the cube root of 14 all over 2. And you might feel like, I really want to divide 14 by 2. But the 14's under a radical. That's not actually a 14. That's the cube root of 14. And that is a plane 2. So. Okay, I'm going to pause. Let's see what you guys do to set it up. It's really the same steps as the last problem with a different number up top. I think, to be honest, I think I assigned too many questions today. I told third period, normally I require 75% completion, 75% right for full credit. I told third period for this one, if they got to 50%, I would give them full credit. So that was really generous because we're almost to 25% right now. Someone said I was being too generous. No. What do you keep it, a 4 or a 2 when you multiply it? Well, you can't multiply it if there's different powers. Does the bottom have to be a full number? At the end. Yes. Yeah. I do want to point out there is something different about this. The number 1,296 is much higher than the numbers we've seen in the other problems. Yes, it's in this list. Did you know that? Look at this. 6 times 6 times 6 times 6 is 1296. So let's write that down and think about it. This should be a number we start to recognize as special. You're growing your understanding of numbers. So let's make the top 6, since it's 6 to the 4th. You hear that, Jaden? Because you saw it. Jaden, you rewrote the top of this as 6 to the 4th. So what I want to tell you right now is that you could just write it as 6. Like the 4th root of 12 is just 6. So in those, because it was a 4th root and a 4, you could have just made that 6 right in that step. That was good that you recognize it. So this is now 6 over the 4th root of 5 squared. Let's call on somebody on the other side of the room. Eva, what's our goal on this one? To get an exponent of 4. Yes, so we want the 4th root of 5 to the 4th this time. So what should we multiply to the top and bottom? We have 2. Yep, we just need 2 more. Squared, yep. So we'll have to multiply in enough to get to the goal. So now we have 6 times the 4th root of 5 squared all over the 4th root of 5 to the 4th. 6 times the 4th root of 25 all over 5. And that is more simple. Yeah. Instead of what? I don't know. If you put this into Big Ideas Math with the 5 squared, does it mark it right? No, it doesn't. Colin, you did it already? How'd you know? You just knew. It marked it wrong with the 5 squared up top. Yeah. So you got to make that 25 for it to check right. Is it right like this? Yes. But because it says simplify, they want it like that. How do you know? Okay, should I stop talking now for a little while and give you some independent work time? No, I can't. This is a whole different problem. All right, you actually have done this in a previous chapter this year, so I'm just going to do one more and remind you about the conjugate.
What?
The conjugate. The conjugate is the same exact expression with an opposite sign over the before the radical or before the imaginary. We did this with imaginary numbers. So we're going to multiply the top and bottom by 2 minus the square root of 5. And when we did this before, we had to distribute and FOIL. So the top is now 2 minus the square root of 5. In the bottom, you have to do double distribution. 2 times 2 is 4. You remember doing this before, everybody? It shows up in this section again. So this is 2 minus the square root of 5 over 4 minus 5. 2 minus the square root of 5 over negative 1. I bet big ideas won't take that. But they're going to make you multiply the top and bottom by negative 1, and this is the answer. So the conjugate is mixed into this lesson as well. This is, yeah, I think you could try entering this into big ideas, it's right. But we don't typically leave negative numbers in denominators. So you just change the signs at the top.